Good morning. Thank you for joining me once again on these examples. This morning we're going to continue with examples under Trig Identities. And our first question, or our first example says we are solving that equation for angles of theta in between 0 and 360 inclusive. And so the equation is cos squared theta plus sin theta plus 1 is equal to 0. You will realize there are very many ways of solving this. The English say there are very many ways of killing a rat. So in this particular one, because we are using trigonometrical identities, we shall first of all think of an identity that links sine and cos. And of course that is our first trig identity which we obtained through Pythagoras theorem. If you remember, cos squared plus sine squared is equal to 1 as long as the angles are the same. So we make cos squared the subject and then replace it in our equation above. And once we replace it in our equation above, we shall obtain that equation in black being written. And so once you simplify or do what we call putting common factors together, you'll obtain 2 plus sine theta minus sine squared theta equaling 0. And this is what we call a quadratic equation in terms of sine. And so if you are okay with solving a quadratic equation in terms of sine, I'll urge that you do that. However, if you are weak at that, then I'll always ask that you replace, for wherever there is sine theta, replace with the normal x that we are used to. And once you solve that quadratic equation by either synthetic division or long division, however, if I use my simpler method down here, I'll obtain the roots as x minus 2 equaling 0 and x plus 1 equal to 0, and my roots are 2 and negative 1. So I first of all consider when x is equal to 2, and if I get the sine theta equaling 2, I'll get no angle in between there. That's why I use question marks. Remember, our maximum sine will always be 1. Any number greater than 1 will always give us mark errors on our calculators. And so we don't have angles there, and we continue with when x is equal to negative 1. And when x is equal to negative 1, once you get the arc sine of negative 1, you'll obtain the angle negative 90 degrees. I'll ask that you continue, you solve that using the diagram and also the general formula to find angles of theta. You must obtain the angles of theta as 270 degrees. That will be your answer. That was part A. Part B, we are now solving another equation in the same range, of course, 360, 0 to 360 inclusive, and this time around we are having 2 cot squared plus 8 is equal to 7 cosec theta. Like the previous example, we also look for a trigonometrical identity that is going to link cot and cosec. Someone else would first of all expand cot and cosec and use the first trigonometrical identity. Like I said, there are very many ways of killing a rat. However, I'll kill it this way. If you make cot squared the subject, you'll obtain cosec squared minus 1, and once you replace it in the equation above, you'll obtain the equation being written in black down there. And so as we put it together, you observe that it is a quadratic equation still, but this time around a quadratic equation in terms of cosec theta. So like I said, if you are okay with solving it using cosec theta, it's okay. However, if you are not, then always substitute in the normal x that we are used to. So as you substitute in the x, you'll obtain 2x squared minus 7x plus 6 is equal to 0. And once we get the roots down there, we shall obtain, once we solve it down, we shall obtain the roots being So we shall obtain our roots as x is equal to 2, x is equal to 3 over 2. And so once we consider for x is equal to 2, remember this time around our x is cosec theta is equal to 2. We can expand cosec theta now, which is 1 over sine theta equaling 2, and we will observe that sine theta is equal to a half. Once you get the arcsine of 2, it will give us our principal value of theta, which is 30 degrees. I'll also ask that you complete that one either using the diagram or the general formula, and you are supposed to obtain the answers written in red below. And so we can now reconsider when x is equal to 3 over 2. So cosec theta will be equal to 3 over 2. Once we also solve that to obtain the principal value, we shall observe that we shall have sine theta is equal to 2 over 3. So that is simple algebra. I do not expect you to be getting lost by now. So once you get the arcsine of 2 over 3, you get the principal value of theta, which is 41.8 degrees. I'll also ask that you complete that one, and you are supposed to obtain the following angles for theta being equal to 41.8 degrees. You'll obtain the angles being written in red down there, and then after our final answer will be an answer composing of angles when theta was 30 as the principal value, and second when theta was 41.8 degrees. Write those angles from the smallest to the largest, and you'll go obtain your final solution. Thank you.